Right now, as we speak, there's this silent, incredibly high-stakes race going on. And it's a race to protect, well, pretty much our entire digital lives from a brand new kind of superweapon.
Okay, I want you to just imagine for a second. What if you woke up one morning and every single password, every bank transaction, every government secret, even your private messages, was suddenly wide open, completely breakable? This isn't science fiction. It's a very real threat on the horizon.
The reason this is even a conversation is because a totally new kind of computer, a quantum computer, is coming. And the day a really powerful one finally arrives, well, experts have a name for it. They call it Q-Day. And that's the day the very foundations of our modern security could just shatter. So yeah, the race to get ready has been on for years.
And look, this isn't just some tech bro hype. The US government's own National Institute of Standards and Technology, NIST, they've made it absolutely crystal clear. They're saying the very methods we use to secure everything, I'm talking online shopping, national security, the whole shebang, what they call public key crypto systems, are totally vulnerable.
All right, so how does this superweapon actually work? I mean, what makes it so different? Well, think of today's encryption like a really, really complex digital lock. It's built on a math problem so hard that our best supercomputers would take like thousands of years to crack it. But a quantum computer, it doesn't play by the same rules. The secret sauce here is something called a Qubit. Now, a regular computer bit is super simple, right? It's either a 0 or a 1. That's it. But a Qubit, thanks to the seriously weird rules of quantum mechanics, it can be both a 0 and a 1 at the exact same time.
The best way to wrap your head around this is with an analogy. A classical bit, it's like a light switch. It's either on or it's off. Simple. But a qubit, now that's more like a spinning coin. While it's spinning in the air, is it heads or tails? No. It's kind of a mix of both possibilities at once, right up until it lands.
So that both at once state, it has a name. Superposition. And because a qubit can explore all these values at the same time, a quantum computer can just chew through a massive number of calculations all at once, in parallel. It's kind of like trying every single key on a giant keychain simultaneously, instead of having to try them one by one by one.
And get this, there is a specific tool designed for this exact job. It's a quantum algorithm called Shor's algorithm. And it just so happens that the very math problem our digital locks are based on, the fact that it's super hard to factor huge numbers, is exactly what Shor's algorithm is a genius at solving. It is, for all intents and purposes, a custom-built master key for our entire digital world.
So, okay, you're faced with a master key that could theoretically unlock everything. What do? Well, the world's top cryptographers didn't panic. Nope, they got to work, building entirely new kinds of locks. This all really kicked into high gear back in 2016. That's when NIST officially launched this huge global competition. And the mission was simple: find, test, and standardize a whole new generation of encryption that could actually survive a quantum attack. It was basically an open invitation to every brilliant mind on the planet. Bring us your best shot.
And wow, did the world respond. At the very beginning, 82 different candidate algorithms were submitted. We're talking teams of experts from all over the globe. The hunt was officially on. And what came next was basically this grueling, multi-year cryptographic tournament. That initial field of candidates got whittled down round after brutal round. After the first round, only 26 were left standing. Then, just 15. And all this time, every single algorithm was just being relentlessly attacked and analyzed by the global community, trying to find any tiny weakness. And then, finally, after nearly a decade of all that work, the first standards were published in 2024. And from that huge initial field of contenders, just 3 primary algorithms were chosen to become the new global standards. Okay, so what are these new digital shields? What did this whole global effort produce? Let's take a look at our new quantum-proofed toolkit.
So these new standards, they have these official government names, FIPS this and FIPS that, but we can really break them down into 2 main jobs. First up, you've got the handshake. Its job is to create a secure, secret connection between 2 parties. Then you've got the signatures, and their job is to prove you are who you say you are and to make sure the data you're sending hasn't been messed with.
Now, the reason these new methods work is super important. They aren't just slightly stronger versions of the old locks. No, they are built on entirely different kinds of mathematical problems.
problems that cryptographers believe are incredibly hard for both regular computers and quantum computers to solve. We've effectively changed the locks to a design that Shor's master key just doesn't fit.
Look, creating these standards was a monumental achievement, for sure. But in a way, it was just step one. Now comes the really hard part. The standards are here, they're ready to go. But now the real work begins, actually migrating the world's entire digital infrastructure. I mean, think about it. This means upgrading the technology that runs our world. Our financial systems, our power grids, our communication satellites, every single server, every web browser, everything that currently relies on that old, vulnerable encryption.
And yeah, this is a massive undertaking. There's no way around it. So organizations all over the world really need to follow a clear roadmap. And guided by experts at places like NIST, the process looks like this. First, you have to find all the old, vulnerable crypto in your systems. Then, prioritize the most critical stuff first. After that, you start the actual transition, swapping out the old algorithms for the new ones. And finally, you have to validate everything to make sure it's all working correctly and is actually secure.
And you should know there's a deadline on this. NIST has put a timeline in place to officially retire the old standards. The transition needs to start, now, with the goal of phasing out the vulnerable stuff completely over the next decade or so. The clock is absolutely ticking.
So here we are. We've seen the threat, and we've seen the solution. The cryptographic tools to secure our future, they're literally in our hands. The race against the machine, in a way, is over. The real race now is against our own inertia. So the ultimate question isn't technical anymore, it's human. Are we ready to make this change before it's too late?